Okay, so as in the last video we discussed about periodic motion and oscillatory motion. What is periodic motion? A motion which repeats itself in equal interval of time. Alright, and what was oscillatory motion? Oscillatory motion is actually a periodic motion, but we have an additional condition to it. It must be to and fro or back and forth motion. Then we concluded that every oscillatory motion is a periodic motion, but not every periodic motion is an oscillatory motion, right? So today we are going to discuss about simple harmonic motion, what it is actually, right? We're gonna study each and everything about simple harmonic motion and the characteristics of the simple harmonic motion, how we can identify that this particular motion is actually simple harmonic motion, right? So we have some characteristics, we're gonna apply to the motion and we're gonna see is the given motion is simple harmonic motion or not. So we are going to study actually simple harmonic motion, right? Simple harmonic motion. We are going to study the simple harmonic motion. Now see, simple harmonic motion. You can take here an example of harmonic as it is an oscillatory motion, right? You can compare this harmonic with oscillatory, right? For now. So simple harmonic motion, which means simple oscillatory motion. It is the simplest form. Simple harmonic motion is actually a type of oscillatory motion, right? It is the simplest form of oscillatory motion. What it is? It is simplest form of an oscillatory motion. It is the simple type of an oscillatory motion. And what have we discussed about oscillatory motion? It is a periodic motion and to and fro or back and forth motion, which means simple harmonic motion is actually the simplest form of oscillatory motion, which means it is of course periodic, right? Which means this simple harmonic motion will going to repeat itself in equal interval of time. Secondly, it is oscillatory, means it will going to repeat itself in equal interval of time, of course. Secondly, that two motion to and fro, back and forth, that two in a straight line. So we have here included one condition, one additional condition. It is periodic initially, right? Secondly, it is oscillatory. If it is oscillatory means to and fro, right? Both included, periodic and to and fro. Third condition is straight line motion. Straight line motion. What's the example of it? Have you ever seen simple pendulum? If you have not seen simple pendulum, but you must have heard about simple pendulum, right? We take we take pendulum's motion as simple harmonic motion. Why do we do this? Now see, this is what we have, the simple pendulum. This is its mean position. We're going to discuss each and every case in very detail, but for now this is just an example to understand what it is actually, right? If we apply some force on it, this body now goes here. This is its extreme position. This is its extreme position, right? Now let's apply the conditions. this is first condition. This must be periodic, right? So this is periodic actually. See, the motion is repeating itself in equal interval of time. If you throw the body here, it will not gonna stop on the mean position. It will initially go to the extreme point and then it will come again back towards the mean position, but of course it will not stop there. It will again go to the extreme point, again it will come here. So of course it is periodic motion, since this motion is repeated in equal interval of time. Secondly, this is to and fro motion. The body is going here, 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 here. Right? So this is what we have discussed in the to and fro motion, right? So this is to and fro motion, which means this is periodic motion, this is oscillatory motion. Third condition, it must be in a straight line. Now see, if I just touch it or throw it with a little distance, right? So this motion must come like this. Ball go there, here, here, there, here, there. So this is straight line motion, right? So this is what we call the simple harmonic motion. This is periodic to fro in a straight line, and simple harmonic motion comes under, you know what, the simple pendulum motion comes under simple harmonic motion. So in the next video we're gonna study the characteristics of the simple harmonic motion. What characteristics we're gonna apply to the motion to check if the motion is simple harmonic or not. We're gonna apply each and every condition to the motion, and we're gonna see is that motion the simple harmonic motion or not. Now everything must be very clear, very clear. Now you can say every oscillatory motion is not a simple harmonic motion, but every simple harmonic motion is oscillatory motion. What we can conclude with this video is every oscillatory motion is a periodic motion, but not every periodic motion is an oscillatory motion. Every simple harmonic motion is an oscillatory and periodic motion, but not every oscillatory or periodic motions are simple harmonic motions. Now I hope these three basic terms must be clear. In the next video we're going to study the characteristics of the simple harmonic motion.